Hi there, I'm Lea. Here's a fun fact you don't know about me. I actually grew up in Greece, and specifically in the island of Lesbos, which technically makes me geographically lesbian, probably the only one you'll ever meet. I like making stuff. You might have used some of my work. You can find all my projects on GitHub. I'm an invited expert in the W3C CSS working group, and I've worked at W3C in the past. And as my day job, I do HCI research at MIT, which is the fancy academic term for usability, basically. And my research is about making web programming easier. You might hear more about it in October, hopefully. And I've written a book. You should buy it. It's awesome. If you have it here, I'll totally sign it for you afterwards, if you want. So, this talk today is about JSUX. What is JSUX? It sounds almost like an oxymoron. JS and UX, I mean, we're JavaScript developers. What do these designery terms have to do with our work? I mean, UX is what we hear our designer colleagues talk about. How does that have to do anything with us? However, if you actually look at the definitions of these terms, they're not just about graphical interfaces like we might expect. For example, usability is the ease of use and learnability of a human-made object. Nothing about graphical interface there. User experience refers to a person's total experience using a particular product, system, or service. Again, nothing about graphical interfaces. And even the user interface is not necessarily graphical. The user interface is everything designed into an information device with which a human being may interact. So, even though what we typically think of as a user interface kind of looks like this, in fact, this is two interfaces, the Google Sheets interface and the browser interface. And yes, surely, every GUI is an interface. But also, a book is an interface. It's an information device. Same principles apply. Making a book easy to read, understandable, it's the same principles that apply to any other interface. Slides are a UI. This slide is a UI. So, you can get a bit recursive there. Even a faucet is a UI, by some very lax definition of a UI. In particular, this faucet is a terrible UI. I took a photo of this in a fancy restaurant in New York. Can you guess how to get water out of this faucet? You probably think that you would lift the lever, right? That's what I thought as well. Nope, nothing happens. You cannot actually lift it. Then you try turning it. Still nothing. Nothing happens. You can turn it, but nothing happens. And then you realize that it's actually motion activated, and the lever is just misleading. And whoever made this faucet realized that it was hard to use, so they realized they had to add documentation. If you look at the bottom right corner, there's an icon showing you how to use a faucet. Pro tip, if you need documentation for how to use a tap, you're doing a bad job. And of course, what is more relevant to this talk, your code is a UI. Same principles apply to making your code usable to other human beings. And the other human beings are not necessarily different from yourself. Yourself in a year is essentially a different person. So I spend a lot of time on GitHub. I have a lot of projects. They have a lot of pull requests. I think they have like almost 2,000 pull requests by now. Hopefully most of them reviewed. This is a screenshot I actually took yesterday. So my GitHub is a busy place. I have to review a lot of code. Thankfully, I have contributors to review some of these pull requests, but still. And this is what made me realize I should give a talk about this. I see a lot of well-meaning people, and I love contributors. I love that they're putting work into improving one of my open source projects. But a lot of the time, I see them focused on adding features or fixing bugs without thinking of how what they're adding is actually usable by other developers. So this is what this talk is about, how to make your code more usable by other people, or yourself in the future. So you might be thinking, what do we need? How does usability matter in code? We have documentation. Everybody looks at documentation, right? So yes, people do look at documentation way more than they do in graphical interfaces, but it's still a last resort. If they cannot figure out what your API does from other examples, or from what they remember, yes, they will look up the documentation, but they will already be pissed off at that stage. They will already be kind of annoyed, unless they're really beginners and they don't know anything about your API. If they know a little bit, they kind of expect to be able to get by. And also, your API should be usable, should be understandable by other people reading code without documentation. So the first principle of good UI design, not just good API design, but UIs in general, make the simple easy and the complex possible. So many APIs fail this very simple rule. They either make the complex possible, but it's simple tasks are really hard to accomplish, or they just provide high-level stuff that, and they don't allow doing complex things. Here's one example from the DOM, and most of my examples are actually from vanilla.js, so that you're hopefully all familiar with it. There is the compare document position method. It's like the Swiss Army knife of comparing the position of two DOM nodes. It returns a bit mask. You can use common bitwise methods to test the relative position of two nodes. And one of the common tasks we do with compare document position is to check if a node is contained by another node. And if we only had this, then it would be kind of a failed API, because it lets you do the complex thing, but it's not particularly optimal for doing the more common thing, just checking if a node is contained in another node. But actually, this is why we have a shortcut, node.contains. It's perfectly readable. You don't need to look up documentation to understand what node.contains does. So I would consider this a good example of API design, even though compare document position is kind of tricky. One of my favorite examples of making the complex possible and the simple really hard is the SVG DOM. I think whoever designed the SVG DOM might have been on some sort of drugs, and you will soon see why. So let's suppose I have this simple circle, and in my JavaScript, I want to get the CX value. Pretty common stuff, right? So I get a reference to it, and then I type circle.cx. How many of you think this is going to return 50? So I cannot actually see how many because of the lights, but not that many. And whoever doesn't think it will return 50 is correct. What it actually returns is SVG animated length. So I can see there that it has a base val property and an animval property. And I'm like, okay, it's a little confusing, but fine, I'll use base val. So I type circle.cx.baseval. How many of you think this is going to return 50? Not that many, I think. And you would be correct. SVG length, because that has to be an object as well. And I can finally see that there is a value property there. So now, if I type circle.cx.baseval.value, now I can finally get 50. Finally. 3 properties down the way. So this is terrible API design. And what makes it even worse is, what if I didn't know about all this? I actually discovered this by accident when I messed up, because I thought, you know, you just do circle.cx, you get the value, you do circle.cx equals some number, and you set the value, right? It's how most properties work in HTML. So what happens if I do circle.cx equals 5, and if I want to change the center of the circle? So the browser just gives me a big old fuck you. If I try to get the value again, it remains 50. It just drops it silently. I have no idea that my value was not picked up. Just nothing happened. So yeah, do not do things like this. So one way to make the simple easy and the complex possible, which will be a running theme through this presentation, is providing shortcuts. Another good way is sensible defaults. This is also incredibly important. Every time you define a parameter, take some extra time to think, what should its defaults be? And absolutely have a default, unless your API makes no sense without that parameter. So One bad example of this is the URL constructor. How many of you have used the URL constructor? It's the vanilla JS way to parse URLs. It's supported pretty much everywhere. So my first thought would be, okay, if I provide a relative URL, it's resolved relative to the document, just like anchor elements are. So I do new URL with a relative URL inside it, and I expect to get an object with that relative URL parsed relative to the document. What do I get? A big old fuck you. Uncaught type error, failed to construct URL, invalid URL. Invalid? It's perfectly valid anywhere else. How is my URL invalid? Well, it turns out there is no default for the base parameter. If you don't do an absolute URL, if you don't provide an absolute URL, you have to explicitly provide the base. How will it be resolved? So I have to keep typing location over and over again. I literally cannot think anywhere in my code where I have used new URL without a location as the second parameter, but I still have to keep typing it because it has no default. And yes, if I provide location as the second parameter, it is happy now. So don't do that. Provide good defaults. Another thing that happens, it's more of a symptom that happens when you don't think about making the simple easy and the complex possible, is that you see your users ending up using a lot of boilerplate. Function calls that are always used together, pretty much in the same order, again and again. Every time someone has to copy-paste code to use your API instead of typing it, you've done something wrong, especially if what they're doing is simple stuff that should really be possible in a one-liner. So how many of you have copied and pasted this in the early days of Ajax before we got libraries and shortcuts, or even those of you who use vanilla.js today? How many of you have copied and pasted this and just changed the parameters? It's a typical example of boilerplate. We need, like, at least 6 lines of code to just send an HTTP request and do something with the response. And well, if the response is JSON. You can save 1 line if it's not JSON. And this is actually better than it used to be. Remember on ready state change? Anyone? And checking if the ready state is 4. At least it's slightly better now, but it's still a lot of boilerplate. Compare that with fetch, which is the new standard for sending HTTP requests. It has sensible defaults. It's pretty elegant. You just pass in a URL. You get a promise as the response. You can call response.json to get JSON if you want. And then you can do whatever you want with that. And it looks so much more elegant. It's so much more readable. Even if I did not know anything about either of these APIs, I can understand what this does much better than I can understand this. Also, this is another API that is really heavy on boilerplate. I do not expect you to read this code. I just wanted to show you the sheer amount of doing the absolutely most basic thing. This is IndexedDB. So as you know, with local storage, you can just set it. It's a one-liner to store a value. It's a one-liner to get a value. And then you realize maybe you need it to be asynchronous. Maybe you need to store more data. Maybe you need something more complex than just a key value store where the value is a string. So you decide to use IndexedDB. And you're presented with this. This is like the most basic example. I was not able to find anything shorter than this. This is actually very, very short compared to any other IndexedDB example. So when you see people having to write this much code to do the simplest thing with your API, this is like just setting and getting a value. It's the simplest thing you can do. And it's 40 lines of code. If people need to write 40 lines of code to use your API in the most basic and common way, you're doing something wrong. You need to rethink your API. You need to provide shortcuts for them. Another really important principle in API design and UI design in general is the robustness principle. The whole robustness principle is be conservative in what you do and be liberal in what you accept. So what it basically means is anything that makes sense to accept as a parameter, if you can deduce what the user meant from it, deal with it. Do not give them an error. Here's an example. Actually, in this case, the URL constructor is a Hall of Fame example. So you can pass in strings. It works fine, as long as they're absolute URLs, as we've seen. But let's get past that. You can pass in other URL objects. Still works. You can even pass objects that look like URLs, like the location object. Still works. As long as it can figure out what we mean, what our URL is, it works. That's a good thing. Contrast that with the new JSUX set constructor. So I want to create a set with one element. So I just pass in one element. And instead, the set constructor will complain. Uncaught type error. Symbol iterator is not a function. What? Here's another thing. Provide meaningful error messages that actually make sense. Like in this case, what it actually wants to tell us is, I'm expecting an iterable as my first parameter, like an array or any other iterable, map, whatever. Instead, it gives us a weird error message about symbol.iterator not being a function. What? Anyway, eventually I figure out what it wants. It wants me to put pointless braces around 42 because I absolutely must provide an array in every case. And now it's fine. Now I can have my set with just 42 in it. So this is another thing. It's good that set allows us to initialize it with multiple parameters. It's good to support mass parameters in every API because sometimes we want to use an API to do one thing, sometimes we want to use it to do multiple things. But you should also support singular things. Remember, make the simple easy and the complex possible. Same thing applies here. So let's look at another common example that I'm sure all of you have done at some point, unless you have not written a single line of vanilla JS. So how many of you are familiar with this set attribute for multiple lines? Most of you. So what I never understood is, okay, set attribute is great when you want to set one attribute with one value on one element. It's fine for that purpose. But why not also accept an object? So we can set multiple attributes. Well, isn't this so much easier to read? I never understood this. Why? And why do we still not have this? Also, a lot of the time, we want to set one attribute with one value on multiple elements. And we have to loop over them. Why? Why can't we just do node list set attribute? So we cannot really deal with this on set attribute because it's a native API, but you can deal with it on your own APIs. A common caveat, like I mentioned, is only supporting mass operations, which I've seen many times. People accepting arrays or object literals, and then you have to use an object literal in every case, even if all you have is one key and value pair. Do not do this. Or APIs accepting arrays, and you have to use an array no matter what, even if you only have one element. We've seen how this is bad in the set constructor. Do not do this. That is stupid. It's pointless extra punctuation that I could really live without. One principle that only applies to JS and doesn't really apply to many other languages is that it's kind of a bad idea to have accessor functions. The date object is a good example of this. So you have to use getMonth and setMonth to set the month of the date object. This is probably because when the date object was designed, people were still really excited about Java. Do you remember Java? How many of you have coded in Java? Quite a few. JavaScript is not Java. When you make design decisions, do not think about all programming languages as if they're the same. Every language has its own features. This is what we typically do in Java. This is boilerplate that is built in to IDEs. And I do not necessarily expect you to read this, but if you have written Java, you're probably familiar with this pattern of defining all your class properties as private, and then adding a bunch of boilerplate getters and setters. get foo, set foo, which all they do is just set the private property that you have. And why don't you make these properties public? Because what if in the future I want to do some value validation? What if in the future I want to run some extra code when these properties are set? Because in Java, you cannot run code when a property is set, or at least you weren't until recently. I haven't written Java for many years. But this is something that most Java developers, it's like their bread and butter. They're so used to doing it. Their entire APIs have features generating these functions for them. In JavaScript, we do not need to do this. We can have public properties if all we need is any of our users to set and get them. And if eventually we decide to do something extra when they're get or set, like maybe validate if the value is okay or run some code or whatever, we can turn this public property into an accessor and the API still works the same. Nobody has to change their code. So why not have something like date.month to get it and date.month equals whatever to set it? It's not just shorter, it's also much more readable. I do not have to parse the function name to understand what this code is doing. It's setting and getting on a syntactic level at this point. So I know some of you might be thinking, at least the ones that know well how the date object works, you're probably thinking, but wait a second, the setMonth function accepts a parameter. So I cannot just have a setter for it with a month property, because it also has a second parameter. And if I'm getting and setting, I only have one value. So yeah, in these cases, it makes sense to have the functions, but you can also have the getters and setters for simple cases. Remember, make the simple easy and the complex possible. It's much easier if I just want to set the month of the date and not provide a day. It makes much more sense. It's much more readable to just have something that looks like a property. In virtually every case, most cases I have used, I have set the month on a date object. I did not provide a day parameter, but sure, some people need to do that. So have a function as well. You do not need to decide between one or the other. So here's another example, and local storage is actually both a Hall of Shame and a Hall of Fame example. I never understood why we have these set item and get item methods. They could be expressed much simpler syntactically. They're just pointless bloat on what we're writing, and they do exactly the same as this syntax, which is also supported. So which is why I have local storage. There's both a Hall of Fame and a Hall of Shame example. Properties are much easier to read. They're much shorter. It's less cognitive overhead for our brain. So you might be wondering, okay, well, if I have a specific property name, sure, I can use ES5 accessors. But here, the user can use any property name. Surely this is some inbuilt browser magic that I cannot really deal with. I mean, we do not have object observe anywhere, so how would I do something like that? You can use proxies. You can pass your object in a proxy, return the proxy to be used by anyone using your API. And the awesome thing about proxies are that you can run code every time a property is set or get on the proxy, or every time someone uses the in operator to check if the property is there, or a ton of things. There are like 12 traps that kind of work like events for what happened on this object, and you can completely customize their behavior. There are so many cool things you can do with proxies. I could literally do an entire talk about them. They're awesome. But in this case, let's assume you had like some set item and get item method, and you wanted to provide property syntax for them. So you would do something like this. The first if is just in case you actually have some properties in your object that do something special. And you can also provide a set trap that calls set item, and a has, and so on. Another very common anti-pattern in API design is parameter traps. You might have heard them as Boolean traps if you've ever read about API design. It's one of the most commonly mentioned things. But they're not just Boolean, which is why I call them parameter traps. This is one of the most common ones. You probably all know what this does. Is there anyone that doesn't know what this does? Okay. You probably all know what this does now, but that's because you looked at the documentation. Otherwise, what the hell does true do in there? Okay, I'm cloning this node. That makes sense. And then true. True what? True, I actually do want to clone the node. I really, really want to clone this node. Please clone this node. Of course, you know that this actually means clone the whole subtree. But that's only because at some point you read it somewhere, you looked at the documentation. There is no other way to figure it out. It's not obvious for someone who has not read about it, who has not heard about it from someone else. Same with add event listener. We're very used to it now. We know that true in there means capture. But otherwise, what the hell does true do in there? I mean, we're adding an event listener on the element. That makes sense. On the focus event, I can still understand that without documentation. And we have a function there. Sure, I want this function to run on the focus event. That still makes sense. True. True what? It doesn't make sense. It's not obvious. If I don't look at the documentation or the spec or something, I would have no clue what this means. And why stop at one when you can have like 10 of them? This is real code that people had to write. Thankfully, we have constructors now and somewhat more sane syntax. But if you want to support older browsers, you still have to use this horrible syntax. And this is why I did not call this section Boolean traps. What does the 9 do? What does the 0 do? Is there anyone in the audience that knows what every of these parameters does? I've actually read the documentation and I don't know what they do. I just don't remember. And this is another case of a bad API. Replace child. I can never remember the order of the arguments, ever. I always have to look it up on MDN. Every single time. Is it new child first? Is it old child first? Do you remember? And of course, the canvas. So the canvas API has a ton of methods that just accept a series of numbers. And well, if you don't know what these numbers do in a demo, it usually tells you, change these numbers to see what each of them is for. Isn't that great? Imagine if you got an oven with no labels, and then it said, press these buttons to see what each of them is for. Lovely, right? You would burn a few meals, but hey, you would have figured it out eventually. Or, think if graphical interfaces worked this way. Hey, here are 4 sliders. Here are all these parameters that I accept. For definitions of these parameters, please see the manual. If we saw something like this in graphical interfaces, we'd be pretty pissed off. We'd be like, which incompetent moron designed this? But in APIs, we're so used to it by now. It's like Stockholm syndrome. And by the way, these 2 examples, the slider example and the oven example, is from Brett Victor's excellent essay called Learnable Programming, in which he made the point that it's actually harmful to tell people play with these parameters to do what it's for, to see what each of them is for, and instead, we should build better programming tools, better IDEs, better editors, which I agree with, but also a lot of the time, you can fix this at the API level. A lot of the time, you can have APIs that are self-explanatory. Let's go back to the canvas ellipse example. So without documentation, it's hard to figure out what these do. Even though I've read the documentation, I'm actually finding it hard to remember. Are the first 2 the center? Are they the radius? I don't remember. But if I had something like this, now it's self-explanatory. And I don't even need to have properties for every single one of these 5 parameters. I can just group them in center, radius, and rotation. And now you can just glance at this code, and you can instantly understand what it does. Or if you want to go all the way, you can have separate Cx and Cy values, separate Rx and Ry values, but I think that's going a bit too far. And of course, we cannot really change the Canvas API at this point, but you can always follow this kind of pattern on your own APIs. And I know some of you might be thinking, but wait a second, I'm writing a lot of function calls to design to draw anything on a canvas. What about verbosity? What about the extra bytes? What about all this extra stuff that anyone has to read? The thing is, code is only written once, but read many times. Think about this for a moment. Yes, you'll type a few extra characters if your parameters are named. But then anybody reading your code, even yourself in the future, will be able to understand what this line does without reading any documentation, and that's very important. So a very easy solution to parameter traps is just moving all parameters into one object literal, or just moving the optional parameters into one object literal, or the non-obvious parameters. And it gives you both labeled parameters. It allows you to have any order. You don't have to think what comes first. Is the center first of the ellipse, or is the radius first? You can just type them in any order you find convenient. And anything can be optional. You don't have to think about putting the non-optional arguments first. And it's good to see that many vanilla APIs are moving towards this direction. For example, the number to locale string method got kind of a facelift recently, or maybe not so recently, and we can do a ton of things with it now. In the past, we couldn't really control what it does. Nobody ever used it because it was kind of useless. It was completely implementation dependent what it did. But now it got a bunch of arguments, and we can use it to format numbers, currencies. We can have digit separators. We can format like currencies with a word like 50,000 euros. It has a lot of cool things, and it accepts multiple locales. So what this function did is the first argument, which is kind of obvious, is not in the object literal because it's both required and, come on, it's obvious. The method is called toLocaleString. The first parameter is a locale. It kind of makes sense. But any other parameter is in an object literal. And it's so much easier to read now. It's so much easier to understand. You've probably never looked at the documentation of this method, and you can understand what this is doing. Similar with add-event-listener. Now that we're adding more parameters to it, like we're adding the once parameter so that you can have you can have listeners that only fire once without any library. You don't need to use jQuery for that. Well, or at least you won't once this is implemented everywhere. But hey, that time's coming. So now you can understand what each of those booleans does. One of them is for capture. The other one is that this listener only needs to fire once. And JSUX makes this really easy with having default parameters and destructuring. So you can have a single parameter that is an object literal, give it a default value straight in the right in the function signature, and then give default values to all its arguments. And then it behaves exactly the way you would expect. If you call it with no parameters, you get the default values. If you call it with an empty object literal, you get the default values. If you call it with only one of the options set, you get option one being that value, and the other one has the default value. It's exactly what you would expect. And it's supported in, well, you would need Babel still. It's supported everywhere now, but only in modern versions. So you would need to transpile. But who doesn't transpile these days? And if you're using APIs that you do not control, and you still want to make your code readable to other people that might not have looked at the documentation, you can just use named variables. So here I used a deep variable and then passed that one to clone node. It seems kind of pointless, but now anybody that reads this, even if they don't know how clone node works, they can understand what this is doing. So we've already seen some examples of unnecessary and pointless error conditions. Of course, there are more. So we've already seen the URL example. And we've already seen the set example. Here's another one. So we create two elements. We do not append them to the DOM. And somewhere down our code, it so happens that we call replace child on them. And of course, we get an error. Failed to execute replace child on node. The node to be replaced is not a child of this node. And this is caused by pointlessly having a third argument to this function, which is the parent of these nodes. The new method, which sadly is not supported anywhere yet, but it's specified in the DOM spec, is to just call replace with on the old child, which saves us from having to remember what the order of the parameters is, and it saves us from unnecessary error conditions. Here you cannot generate an error like this. If you call replace with on these two divs that are both not in the DOM, browser will be like, sure, okay, dude, I've replaced them, sure. Of course, nothing has happened because they're not in the DOM, so what does it mean to replace them? But you didn't get a pointless error. Another big one is people who add parameters without any thought about their order. And this happens surprisingly often, even in vanilla APIs, native APIs in the browser, which you would expect there's some more thought behind them. My favorite example of that is the history API. How many of you have used the history API? A few. So every single time you use the history API, you have to provide null as the first argument and an empty string as the second argument. Sure, these arguments actually do something. The second one is what should be the title of that state, and the first one is a state object. But who remembers? No, the title per argument is not supported by any browser. No browser actually does anything with it. And I've never known anyone that actually used the first parameter for anything valuable. You just have to provide these values, null and empty string, over and over and over again, so you can actually get to the third parameter that's the one you actually want to set, which is your actual URL that you want to push in the history, Why couldn't the URL be the first parameter so I can just omit the other two? We'll never know. Double negatives is also a pretty common one. Things like hidden equals true instead of visible equals true, or disabled equals false instead of enabled equals true. Why does it have to be disabled? So that when we set it to false, we essentially have a double negative, and we have to think, disabled is not enabled, so I've set it to false, so it's not enabled. Wait a second, that is enabled. I mean, sure, our brains do this really fast, but it's still cognitive overhead. You don't realize because your brains resolve this in a few milliseconds, but it's still cognitive overhead that it's better if it isn't there. Having Boolean parameters that are true by default is kind of a small anti-pattern, because absence is a negative concept. We tend to think as something not being there as false instead of true. So we have to think more when a Boolean parameter is true by virtue of being absent. Also in JavaScript, Booleans are essentially true, false, and undefined. So undefined is falsy. So it makes much more sense for JavaScript developers if undefined is actually treated as false instead of true. And it's also easier to code for. Here's an example. I'm not advocating that deep should be false by default. That would not be sensible default, remember? If you do not provide the deep parameter, it should absolutely be true by default. However, you can instead reverse what the parameter does, negate the concept, and instead of having a deep parameter, have a shallow parameter, so that when the shallow parameter is omitted, it is false. You cannot always safely do that without making a bigger mistake in your API. So this is kind of a smaller advice. For example, let's look at number 2 locale string again. There's a use grouping parameter that is true by default, because usually when you're using this function to format numbers, we want grouping. So it's true by default. So we're thinking, how could we negate this concept? There isn't really an obvious way to negate this concept. Use grouping is a good name, it makes sense. So there's no real way to, of course we would not want to use something like no grouping, because that will be a double negative. Think of no grouping equals false. That's not a good idea. So when you have to choose, sensible defaults are more important than double negatives, which are more important than Booleans not being true by default. Another thing that mainly applies to JavaScript is chaining. So you might have realized by now that many of these principles that I'm discussing are things that jQuery did right. That's why it got such adoption. There are many API design principles that jQuery got right. Think of earlier on when we showed set attribute and we were like, why does it not apply to multiple elements? Why does it not accept an object literal? That's exactly what jQuery's function did. And this is another one that jQuery did right. Every method is chainable. So let's look at set attribute again. What I never understood is, why does set attribute return undefined? It's so pointless. You can't do anything with the return value. Why could it not have been like that instead and return this? Or same with the Canvas API. It's so annoying to have to type the Canvas context again and again and again. It's one of the reasons people mostly use libraries to interact with the Canvas. Why couldn't it have been like this? It is so simple to make APIs chainable. All you have to do is return this in all your methods that don't return any other value. Returning undefined is wasteful. If people do not want to use your return value, they can just not use it. But returning this at least gives them the option to do something useful with the return value. And you can even do it in a mass way. If you don't want to keep typing return this on all your functions, you can just have a chainable function that accepts a function, makes it chainable. And it's like literally as simple as this. It's just 4 lines of code. I've even written a small library at some point to do this very thing, to make native APIs chainable, because of how JavaScript lets you modify pretty much every object. So you can even use that to make native APIs chainable. You just check if the value is undefined, and if it is, you return this. Redundancy is another big problem done by many native APIs. Thankfully not anymore, but the DOM API is full of redundant parameters everywhere. Think of remove child. If I have to write vanilla JavaScript, this is like the first helper method I make, a function to remove elements, because otherwise you have to type your element twice, and if your element is the result of an expression, you have to use a pointless variable. Why? Why didn't we have element.remove earlier? Now we do. Now it's supported in every browser. But for many, many years, we had to do this horrible thing. Same with insert before. Pretty much all the DOM methods are fucked in this way, the old ones. Why do I have to type element.parent node insert before new child, comma, element? Which is element is the element I want to insert before. Why isn't it just this? Which we do have now, at least in the spec. I don't think it's supported yet. But at least now we're starting to get some sensible methods, and also after, which we did not have in the old DOM. So the takeaway from this is, if any of your parameters can be determined by other parameters, do not force people to provide both of them. Both for dry reasons, because otherwise every time they change one, they have to change the other, and that is against dry, don't repeat yourself. Also because it's pointless verbosity. There is a saying that there are the two hardest things in computer science are naming things and cache invalidation. We're not going to talk about cache invalidation today. But this is a good rule of thumb for naming things. Use few simple words whole. It sounds obvious, but it's striking how many APIs do not do this and instead use fancy technical terms that only the API creators understand. And you can learn anything. Even the worst API, you can learn to use it eventually. But the more weird your names are, the more long they are, the harder they are to learn. A a small example of this that you're all familiar with at this point is parent node. Why did it have to be parent node? Why could it not have been just parent? We do not have another parent property. Why couldn't we just say element.parent? This is another thing that jQuery did right. It does have a parent method. Similar with child nodes. Why couldn't child nodes be children? And yes, I know, children are just the element child nodes, but that came after. When child nodes was defined, there's absolutely no reason to not call it children. Instead, this is confusing. It doesn't make sense that children are just elements and you have to use child nodes to refer to all text nodes. Instead, this should have been element children or something, just like first element child, last element child, or all of those properties that have element as something added in their name. And yes, I know this seems very trivial now because we're so used to it. But if we were learning the DOM API now, and many people are, it's a point of confusion. Also, describe what it does. That's another principle about naming. Describe what it does, not how it works. I do not, when I'm getting elements by a selector, I'm not thinking of this as querying. Querying in my head is more like SQL, or heck, even XPath. But people do not think of finding an element by a selector as querying. Yes, I know technically it is querying, but remember, what it technically is does not matter. What matters is how people think about it, and people think about it as finding elements. So even though at least the new methods, so yeah, we're getting these new methods soon, which it's not just the name that changes, but also a few other details, like they accept partial selectors. So these are slightly better, because at least they're shorter. I don't know a single person that has used query selector all more than once without aliasing it to a function. It's one of those like first functions that we make every time we have to write vanilla JavaScript for some reason. So even though this is shorter, it's still kind of confusing to newcomers. Like, query? Seriously? Find and find all are much better names. And we would have had them. That was the original plan, but there were some compatibility issues with, I think, some versions of jQuery. Do you remember, Yehuda? Yeah, me too. This would have been such better names. Anyway, so is life. So the jQuery dollar function is a very curious example of API design. It violates pretty much every principle about making names understandable. Newcomers always find it confusing. What is the dollar function? Especially given the fact that it's used by more than one library. jQuery started it, but now pretty much every DOM helper library uses it. My own Bliss uses it. I get a lot of people seeing Bliss code and being like, but where's the jQuery? There's no jQuery. So I'm a bit ambivalent about this pattern because the real world proves that this was actually a good idea. People loved it. It was one of the reasons that jQuery became popular, both because you could get elements by selectors, which back then was not a thing you could do natively, and also because it was so easy, so quick to type, just one letter. And so maybe there is an exception to be made here about functions that you use over and over and over and over again, so much that so much that reading them fast becomes a priority over understanding what they do just by their name. But do not use more than one or two of those in a project. So another good idea, which of course has its exceptions, is responding to changes. I did not find a vanilla JS example for this because at least every API seems to get this right. Every native API seems to get this right. But there are so many examples of third-party libraries on the wild that do not do this. My favorite example is this masonry script, which is a bunch of scripts doing fancy layouts, which are really nice for images. I've actually used it. The results are really beautiful. It's used to lay out images in those kinds of ways where every image has a different size and it all looks kind of like a nice composition. Has any of you used any of these scripts? Quite a few. Yeah, because these layouts are nice and they look nice and they're trendy. One thing I do not like about this library, and I do like its results, I love its results, they're beautiful, do not get me wrong. One thing I do not like is that every time I add a child, every time I make any modification to my DOM, I have to call packery.layout so that it relayouts and I get a nice fancy layout again instead of something that looks broken. So now every single bit of my code that does anything to those DOM elements has to know that I'm using Packery. If I decide to use another script, I have to go everywhere and replace these and remove these calls. It makes my code terribly coupled when it shouldn't be. In JavaScript, we have mutation observers. And we used to have mutation events in the past, but these are advised against. They were super slow. But we now have mutation observers. They're much faster. And we can use them to observe changes to the DOM, like attribute changes, new elements being added, text nodes changing, anything. The only things we cannot observe with mutation observers are things that are not reflected in the DOM, like a checkbox being checked. But for the purposes of layout libraries, mutation observers work great. And we can create the observer that just calls packery.layout, and then we can call it on our grid element and we can tell it to just observe changes to child list, so that we are not being wasteful and observing pointless changes. And there are some other observers being planned, which I believe now only have support in Chrome, the first two. Resize observer for when an element changes size for whatever reason, and intersection observer for the relative position of an element in the viewport or to another element when that changes. And also a bunch of Houdini specs, which is a new initiative from the CSS working group to expose a lot of built-in browser magic to third-party developers so that people can, for example, build their own layout libraries that work exactly as well as built-in layout methods. It's a very exciting initiative, and there's a ton of specs around it. This could make a talk of its own. So I know some of you are thinking, but mutation observers, won't somebody please think of performance? And you do have a point there, but if used with restraint, mutation observers can be very useful. Just observe as little as possible. Do not observe things in the entire document if you can. Limit them to specific elements. Narrow scope as much as possible. Unobserve when you don't need to observe mutations anymore. And do not force it on your users. Provide a way out, or a way in if you want to make it opt-in. Some people might prefer to cut the tight coupling that not observing changes creates. They might prefer that over the slight performance loss. So give them that choice. One of my pet peeves when it comes to JavaScript, because it's just so easy to avoid, is forgetting to include toString and toJSON methods in your code, in your classes. Because it's just so easy. You can provide a toString method or a toJSON method in just one line of code, basically, and it will do something much more useful than the default ones. So a bad example of this is the attribute classes. So every DOM element has an attributes property, which returns a map of all its attributes, which is useful when you want to iterate over all the attributes of an element. However, you have to always use this as an object. If you try to convert it to a string for whatever reason, for example, debugging, if you want to console log something that includes this, you just get object attr. Super useful, right? So, as some of you might be able to tell, that just means it has no toString method of its own. It's just inheriting one from object. We already have a toString method that converts objects to braces, object, and class name. That's the default object to string method. So nobody that designed this API bothered to think about what it should convert to. I never understood why they couldn't have done something as simple as this. If this was our own class, we could just add a toString method that returns name equals value, and then we have something much more valuable if we want to, for example, debug. Then if we run the same code again, we get lang equals n, which is like the first attribute of our HTML element. Something much more useful, something that actually reflects the contents of the element in some way. A good example of providing a toJSON method is the date object. So date objects are not allowed in JSON per se. They have to be converted to one of the JSON primitives. So date has a toJSON method that converts it to that serializes it to the ISO format, which preserves pretty much every bit of information about it. So we can then pass this string into a new date constructor and have a date object that reflects the same date again. Unfortunately, not every native object has the same convenience. Regex objects, for example, don't have any toJSON method. If we try to convert them to JSON, we just get the default empty object. Super useful, right? So this is what will happen to your own objects if you do not provide a toJSON method. And it's so easy to provide a toJSON method. It's such a shame not to. And lastly, the best JavaScript API is actually no JavaScript API. And yes, I'm saying that at the JavaScript conference. But think about it. Even the most hardcore JavaScript fan typically finds it easier if things have a way to specify them declaratively in HTML. At some point, but it's not just about what you prefer, what JavaScript developers prefer. It's also a matter of accessibility, if you may. Not everybody is familiar with JavaScript. At some point, I asked on Twitter, attention, people who write HTML and CSS, how comfortable are you with JavaScript? And half of the respondents, and that's a lot of respondents, actually. I got 3,578 votes. Half of these people who do write HTML and CSS are not familiar with JavaScript. Either not at all, or they're only somewhat comfortable with it. So yes, there are many libraries that just simply cannot have an HTML API. Code-level libraries, for one. jQuery could not have an HTML API. It would make no sense. But any library that does something GUI-related can have an HTML API. It can have a declarative way to use it. One of my favorite examples, one of my favorite anti-patterns is pretty much the entire jQuery UI library. So to create a slider with the jQuery UI library, you have to include an element, any like random div or whatever you want. And then you have to call a method on that and provide all the parameters in an object literal. Why couldn't you just provide these elements on your these parameters as attributes on your element and like have something like class equals slider and it just figures it out? The HTML5 gets this right. So the previous jQuery UI example was to do a slider with two handles, which is why it has range equals true. And in HTML5, you do a slider with two handles by using the multiple attribute, completely declaratively. I'm actually using a polyfill here that I wrote because it's not supported anywhere. But that's what is specified. You have a slider. The slider is supported, just the two handles are not. You create a slider by just input type equals range. If you want two handles, you add a multiple attribute. The value contains the initial value, two of those if you have two handles. The max is the maximum value of them. Step is the increments. Completely declarative. You do not need to know JavaScript to create a slider in HTML5. You do need to know JavaScript to create a slider in jQuery UI. Why It always escapes me. Here are some principles of HTML API design, and we'll discuss them in the next few slides. Have an init selector. Have a selector that if elements match this selector, they're initialized automatically. You do not need to call a function on them. And what the selector is depends on your script. Maybe it's just a class that you add on elements that you want your script to pay attention to. Or, in some cases, it's just a selector that can occur naturally in markup. For example, if you're creating a polyfill for multi-range sliders, then you just match you just match input type equals range with a multiple attribute. Or if you're making a syntax highlighter like Prism, you just match pre-elements with a code child or code elements that have a language something class. It really depends on what you're building. Just have some way for people to initialize something in HTML instead of forcing them to call a function, because for you it might be trivial, but for them it might be really complicated. And there are ways to provide settings directly on the element without having to call JavaScript. Boolean settings can be either classes or attributes that people use without a value, like if it's there, the setting is true. If it's not there, the setting is false. String and number settings, you just use data attributes. If you want to link to it, if a setting is an object, like an array or something, you link to another element by providing a selector or an ID in the attributes. And if some of your parameters is a function, well, you can't really do anything there. If somebody can write a function, they can write JavaScript. So whatever, just have these as JavaScript only. But in most cases, you do not need function parameters for basic uses of an API. They're more for like advanced customization. So have an init. So this is an example from Prism, my syntax highlighter library, which is used in many big websites. So Prism picks up any element with any code or pre-element with a language something class, which is the way the HTML5 spec says we should define the programming language of a code example. We should not use the lang attribute. We should use a class. That's what is defined by the spec. So essentially, it's init selector. It doesn't even have to do with Prism. You do not need to know that Prism exists to use it. If you write proper markup, if you mark up your code examples with the language they're using, like the HTML5 spec suggests, you can just drop Prism in your page, and it just works. You don't have to do anything, which is useful even if you do know JavaScript. So this is what Prism's init selector looks like. It looks for code elements with a class of language something, or elements with a class of language something that include, or code elements that are inside something with a class like this. Another example, and this is from native HTML, for providing parameters is sliders again. So we've seen how you provide the maximum value and the step value, which is the increment. And this is how you link to an array of autocomplete options with the list attribute. So the list attribute on a normal textual input just lets us define autocomplete options, which is super useful that we can do this natively now. But on a slider, it lets you define ticks. So I can change this here. You can see how the ticks change. What I found yesterday that was super interesting is that if you change the step so that some of these ticks become non-reachable, you can see that they disappear, which doesn't really have much to do with this talk, but I thought it was interesting. A hall of shame example, on the other hand, again from native HTML, is the dialog element. The dialog element has the really nice feature that you can open it by just adding an open attribute. This is great. This is a declarative way to open the dialog element. It's great. And then you can close it, by removing the open attribute. Even if you do know JavaScript, this makes things easy. On the other hand, even though the dialog element provides native modal dialog functionality, you have to use JavaScript to use that. You cannot do something like open equals modal or something. Nope, that will not work. It will just open it as a normal dialog. If you want to open it as a modal dialog, you have to add some JavaScript that launches it. I'm going to use inline event handlers here just so that I have everything in one demo. Bear with me. So you have to use the show modal function on something. You have to call it somewhere in your JavaScript. Let's give this a label. And now this opens a modal dialog. As you can see, this is completely, not everything behind it is completely inactive, and I can close it by default with the escape key, or I can add my own close buttons. Why did I have to call a JavaScript method to open this? I can open it, if it's not a model, I can open it with an attribute. Why can't I do the same if it's model? I don't know. If you're using settings in HTML, sometimes it makes sense to make them inheritable. This is one of the things that people really like about Prism, that if all the code examples in a certain element are the same language, they do not have to keep defining that language. They can define a language on the body element for all their snippets, then they can define a language in another element for all the things that it contains. Then they can define language classes on individual elements. In fact, I believe I've done this on this particular slide deck. See, body class equals language JavaScript, and somewhere I have, in this particular section that I'm showing you now, I have language markup because most of my examples there are HTML. So in some cases, inheritance makes a lot of sense. Consider if, in your case, it does. If you're creating a slider, for example, it makes no sense to have inheritable settings. If you're creating a syntax highlighter, it does. Think of your use case. And sometimes you need to provide global settings. You can provide those on either the HTML element, body, or the script element. Ideally, all three, because remember, be liberal in what you accept. Some people cannot modify the markup of script elements they include because they're using some weird CMS. You might be thinking, well, if they provide these settings on HTML or body, then I know how to get them. Document.document.element, document.body. How do I get them from the current script that they use to include my library? Well, actually, thankfully, we have document.currentScript, which lets you get the current script. And then it's just as simple as if they provided these settings on body or HTML. And maybe, I'm hoping in the future, we might start having CSS APIs. Let me zoom this in a bit. So this is the polyfill I released recently for multi-range inputs with two handles because they're not supported yet. So it's just basically overlaying two native sliders to create a multi-range slider. And in CSS, I've used, I've told people what CSS properties I used so that they can customize the widget easily and skin it. For example, if they want to just change the color between the two handles, they can just use the range color custom property. And I expect to see a rise in these kinds of CSS APIs as CSS variables are supported everywhere. Now they're supported everywhere except Edge. So I'm looking forward to giving a future version of this talk where it has some CSS API design principles as well. So I'm about, before I leave you, some parting words, some general advice for designing UIs and APIs. First, cherish the knob within. It sounds a bit weird. It sounds like counter-advice. Well, I do not want to be a noob. What do you mean by cherish the noob within? What I mean is, when you first start learning about a library or an API, you're a noob. And then eventually, you struggle and you push through and you read documentation, you read tutorials, and eventually you become from noob to expert, hopefully. And then this becomes a rite of passage to other people. And you're like, hey, I went through all this. Now it's easy. Come on, how can you not understand this? It's easy, it's so easy. Noob. But the thing is, once you become an expert, you're useless for usability. You know too much. It's the noob that will discover the usability mistakes in an API. Once you're past that stage, and like I've said, you can learn to use any horrible API. With given enough time, you can learn to use anything. What differs is the time you need. So once you're past that noob stage, you cannot figure out usability problems anymore. You need someone else. You need another noob. Unless you, so you should try to keep that feeling a little bit. You should try to keep that thought process. Remember how you were thinking. Keep notes. As you're learning about a library, keep notes. What did you find difficult? They will make you avoid the same mistakes. And sure, not everything you struggle with when you're learning about an API, not everything means it has a usability problem, but a lot of them do. A lot of the time you struggle on things that everybody else struggles with, and everybody else also thinks it's their own problem and they're just being stupid. A lot of the time they're not being stupid. It's just that the API is indeed badly designed. Usability is really hard. Even if you studied usability, even if you try, you will still make mistakes. You'll just make fewer of them. If you have time, it actually really helps to see someone else use your API. And yes, it's extremely hard because you keep thinking, oh, how can you be so stupid? How can you not get this? It's just this, it's this. How can you not get this? Come on. Doing usability studies is really hard because of that. You have to keep telling yourself to shut up because the user is not stupid. It's a lot of the time it's actually your API that has a problem. And if you try to code with empathy, you will stop a lot of usability problems in their tracks. Just try to get in the head of your user. Try to think how your code will behave when somebody else is using it. Don't just think, I want to add these features, so I'll just throw something together. Think of the experience from the user's perspective. Try to use your library. What I find really, really helps is if you try to think how you would want your API to behave before you start even thinking about writing code. Because then you're not making decisions and cutting corners based on what is easier to implement, but based on what is easier to use. I think a lot of the usability problems I see on APIs would have been prevented if the developer actually thought in this way. You don't even need to know any usability principles. You can figure them out if you just think in this way, if you just have empathy towards your users. Think about using your API. Does that user want to kill you, or is it a pleasant experience? Do not be someone that your users want to slap. So that's about it. Thank you very much. And you can find my slides online over there. If you have a question, you can find me on Twitter. My email is over there. I'm not sure if we have time for questions.
We do have time for a few questions.
Nice.
People want to see your Twitter slide.
My what slide?
The voting side. The screen with the votes that you got.
Oh, the screen with the votes about what this keynote will be about, or the one about HTML versus JavaScript? The one I had here, you mean? Okay. I can send you a link to it. I had it pinned at my profile for a while, but now it's not. Actually, I have a link in those slides. This image is actually a link to it. So if you load my slides, then you can find it on Twitter as well.
Yeah, highly. So most of the solutions you presented are essentially makeover or facelift of the existing DOM, which we have to accept that is 2 decades old.
Yes.
Okay, so why don't we retire it and create a new breed of browsers with completely new DOM? Let me finish. And why not just browsers, but for all the native platforms? Okay, so why not just browsers, but all the native platforms that we have, be it Android, iOS, Windows, I don't know whether I should count BlackBerry as well, so that we developers don't have to go through all these pain points. Okay, we write something that works across all the platforms. So now, for example, React Native is saying is 80% reusable. Why can't we make it 100% reusable across platforms?
So is the question about why are we not retiring the DOM, or why is React not 100% reusable? I'm a bit confused.
I think it's a very long question.
It's mainly to do with DOM.
So I would love to live in a world where we could do this. Unfortunately, there's a lot of existing stuff on the web that uses these old DOM methods. This is a huge concern in standardization. I see it in the CSS working group all the time. There are tons of design mistakes in CSS that we just cannot change anymore because there's just so much content using it. And it's the same with JavaScript. So the way you retire an API is not by dropping it altogether unless it's not used anywhere. This has also happened. But a widely used API, you just cannot drop it from the web platform that easily. The way you drop it is you define something better, you get people to use the better one, and over time, people will use the old methods less and less and less. And at some point, it might become safe to drop it completely from browsers, but even if we don't drop it, we have the new methods to use. Like the insert before and before methods, or remove child and remove element.remove.
Right.
We're slowly getting better methods.
Yeah, so I'm not aiming at the current user base or the current web developers at all. I am aiming at the next generation of web developers who are ready to switch over to the new DOM the way people are now switching over to ES6 or ES7, So we have to adapt to it.
You can do that with polyfills. You can use the current DOM, the new methods today with polyfills. Thankfully, JavaScript is really easy to polyfill. The main problem is that there's a lot of training material already online that people use to train themselves, and it's outdated. Like people Google tutorials for the DOM when they're learning, they find all this outdated stuff. Or Stack Overflow answers, that's like my favorite. Every time I Google something and I stumble on a Stack Overflow answer, it's usually answering based on like how the state of the web was in 2010. And even answers given today, like it takes a long time for people to update and for tutorials to update. And this whole migration just takes a very long time. It's not just about defining new methods and having them supported in browsers. Thank you.
Any other questions?
We do have a question from the back.
Yes. So you have explained. So you explained about the CSS APIs, right? Mm-hmm. So is there any link? I mean, where we can play with these CSS APIs or something?
So what I said was that now that we're having custom properties, basically any property prefixed by 2 dashes is a custom property, and it can have any name, and you can refer to it with the var function. This is supported everywhere except Edge right now. They're called, you might have heard of them as CSS variables. So I was saying that as this becomes more widely supported and people start depending on it, I expect we will start to see a lot of widget libraries saying, use these CSS properties to theme our widget, because then they can use them in multiple different properties. Like you define a color, and then they can use this color in their background as a background color in some elements, as the text color in some other elements inside the widget. So they can adapt. They can adapt a lot based on like a single value you provide. So that is just my guess that I expect to see a lot of sort of CSS APIs, like libraries telling us use these CSS properties to do these things, which is kind of like how JavaScript APIs work in a way, like use these functions to do these things.
I think we can take just one more question.
Yeah, can you elaborate more on the resize observer, what we can expect?
About the resize observer?
Yeah, can you elaborate what is in progress and what we can expect from it?
Right, so just like mutation observer lets you run code every time the DOM changes, resize observer lets you run code every time the dimensions of an element change for whatever reason. Like maybe the font size changed due to some CSS. Maybe the content changed, which would also fire a mutation observer. Any reason that causes the dimensions of the element to change, you can catch that with the resize observer. Whereas today, without a resize observer, there's no way to do that. There is a resize event, but it does not fire on elements. It only fires on window.
Right. Okay, I think this was fantastic. Thank you. Thank you very much, Lea.
Thank you very much.
Before you go off stage, we do have a privilege. Chris, who is the inventor of SVG, who is sitting amongst us. Chris, can you come on stage, please?
Yeah.
Chris?
You've done all the damage.
Can we have a big round of applause for Chris?
I have nothing to do with this.
Can you say a few words of wisdom?
No pressure.
No pressure. I'm really pleased to be here. This has been an interesting conference. In the last month, I've been traveling to various conferences and hearing real developers. There's a risk working at W3C as I do that you talk to other standards people and you don't talk to actual developers. And so it's really good you hear the same conversations over and over, people say, and you come back, oh, there's this thing. We've got this thing. Everyone's got this pain point. Everyone's got this problem. Everyone has this issue with JavaScript or this issue with CSS. And that really is valuable to feed back into the standards process and keep us rooted in the real world. So thank you very much for the opportunity.
Yeah.